My name is Jordan Letterman. I am the Director of Infrastructure for a small internet company called Advanced Internet, where we host privately run news and websites, and I'm a longtime 3PAR customer. I'm here with Manish. You can introduce yourself.
Thanks, Jordan. So my name is Manish Jain. I'm a storage architect at 3PAR. In case you haven't heard about 3PAR in the past 2-3 weeks, we're a storage company based out of Fremont, about 11 years old, about 600 employees. And we're going to talk about things to know when you're choosing storage for your ESX virtualized environment. So I'm going to start off with just a couple of slides on just level setting where people are, what we've seen. So this is a Taneja Group study. They interviewed Fortune 500 companies, and this should be old news to most of you. Savings, whether it's CapEx or OpEx savings, is the number one driver for virtualization. The interesting point about this slide is only 35% of workloads have been virtualized in an IT data center. So this means the majority still is left to be virtualized. Oops, wrong way. Okay. So challenges with storage in virtual environments. Almost 40% said storage has not detracted from their ROI when they decided to go virtual. And then if you look at the next one, there's 35% that have said it hasn't. So 40 said yes, and 35 said it really hasn't. And you're kind of wondering why that big difference. And part of the reason could be that some people are way ahead in their virtualization endeavor. Some are just starting off. So depending on where you are, if you pair it up with the right storage, then things are great. If not, then you're going to run into issues. The next one, you get storage. All storage is not equal. If you look at it, capacity and performance are the top two things that people complain about when they don't get the right storage. And then the last one is what's determining what to virtualize and when, and security and performance. So there might be an application that you want to virtualize, but performance, once you know when you virtualize it, performance might go down. That becomes a factor that people are using of not virtualizing. And then what you want at the end of the day is to drive up your ESX, your VM density per ESX host, because that'll bring down your storage costs and overall costs in the environment. So if you look at this one, if you look 33% and 15% have gotten 6 to 15 VMs per ESX host. So you want that number to go as high as possible because that'll save you more money. So if you don't pair up with the right storage, you're probably not going to get to that 20, 25, 30 number that people are reporting. So if I summarize the previous 3 slides, your objective is to increase your consolidation, but then the challenge is if you don't have the right storage, you might be virtualized as far as your servers are concerned, but then you're paying the price on the storage end. If you don't have the right storage, you might be spending way too much time managing that storage, whether it's provisioning, allocating disks, etc. And then maximizing savings. So you buy a storage array, you get the capacity, you get the performance, but generally those two things are not correlated. They don't go hand in hand. So if you get performance, you're sacrificing on capacity. If you get capacity, you're going to sacrifice on performance. So you decide you're going to virtualize everything. You're going to go with VMware. And this slide, and this is from VMware sources, by the way. What they're showing here is a before and after picture. So before you had a physical server, and after you consolidate 10 VMs on that physical server, you'll notice memory utilization go up the most in this example. Part of the reason is ESX relies heavily on overcommitting memory for its ROI. So if you're running out of memory for your VMs, what happens? ESX uses page sharing. The latest is now memory compression. I don't know if you guys heard about that in the sessions here. But page sharing, ballooning, and swapping are some techniques for managing memory pages. For both ballooning and swapping, you need a storage subsystem that can keep up with the demands of ESX, so something that's high speed, low latency. So, looking at other challenges, you have an ESX host, it's got a bunch of VMs on it, they're all doing something different. The I/O pattern of that ESX host is pretty random. A random I/O means you have to go to disk more often, then you're going to find stuff in your storage cache. So arrays with large caches, yes, they might be helpful, but at the end of the day, because of the random nature of ESX, a large cache is not going to be that much of a help in a VMware environment. The third bullet, so you have an ESX host, it's got a bunch of VMs on it, you're not getting the performance, what do? With traditional arrays, you keep adding more disks. Basically, you want to get as much IOPS as you can behind that ESX host. If you keep adding more disks with traditional arrays, what happens? You've now increased your capacity just to get performance. So you might have a lot of wasted capacity in that volume that you're presenting to ESX. So these are some common challenges that people face with traditional arrays, whether it's modular, active-passive type controller architectures or monolithic, sort of the EMC style arrays. Here's top 3 to 5 bullet points to keep in mind.
Hey, this is me. As I said before, I work for a company called Advanced Internet, and when I came into a systems management role, I walked into a situation where we had a lot of echo. I walked into a situation where we had about 300 servers, all with local disk. We had a couple of big initiatives going on where we were starting both with VMware and with Oracle. This was about 5-6 years ago. And we knew that we needed a SAN, but we really didn't know what we needed in a SAN. And sales teams being what they are, we came into EMC and picked up an EMC Clarion. It was bigger and more expensive than we thought it was going to be, and it turned out to be a lot to manage. It really took the management of what we thought was going to be the application and made it twice as much, because we were dealing with complex storage on top of what at that time was a complex application to us. And as we started to get into VMware, we said, hey, great, we have a Clarion. We can use this. It was an older Clarion, but it didn't work out well for us. Oops. So, dealing with the Clarion, my problems were that I couldn't see what was going on. Even if I knew enough at the time to really understand what was going on, the data wasn't there. There was no tools to report on it. There was no GUI to tell me what was going on right now, or why it was going on right now. I could see small things like how many IOPS a LUN was doing, but not where things were queued, or what type of operations were taking longer to complete as opposed to shorter operations. When I had these performance problems, I opened support cases. I never, to this day, I've retired the devices from production, and I've never gotten a good answer on the support. I'd get, they'd be really helpful when I had a system down type of issue, a real critical, you're offline, but for something that's not as fast as it should be, I couldn't get anything out of them. I would get a PowerPoint sent back to me 3 weeks later with slides talking about something completely different, and then I'd send it back. And it was expensive. When I did get answers, mostly from my SE, it was buy more disk for more IOPS, because I had to dedicate disk for certain volumes as opposed to share things. So there was a solution with 3PAR. I met 3PAR probably about 4 years ago. Yeah, 3.5, 4 years ago. They told me about this great new S400 system that's multi-node, but all one system, how it uses a pool of disks that you carve your volumes out of, so you don't have to dedicate separate spindles to separate applications. You get the power of all spindles on all your applications. And once I implemented it, it turned out that when I wanted to add VMs, or when I ran out of space, I would just buy more space. I had the IOPS there because I was able to share the spindles across everything. It's a massively interconnected, massively scalable system, and Manish can speak better on how it connects.
Yeah, so this is not a deep dive on 3-part technology, but I'm going to just highlight a couple of things. So what you're seeing here is an 8-node system. We can start off with 2 nodes. We're an active-active architecture. And you can keep adding nodes as you grow in 2s, up to a total of 8 nodes. Adding nodes is totally non-disruptive, transparent, and basically what happens is all of these nodes are connected to each other through what we call a backplane, which is basically a circuit board. And as you add nodes, so you start up something in a 2-node system, you add 2 more nodes, you basically double your performance.
I started with a 2-node system and grew from there. I never added nodes, I just added disk.
So the other thing that's kind of unique about us is if you look on the left-hand side, this is a traditional array. It's a active-passive architecture, so it's a modular array. And what you do in this example here is when you're creating a volume or a LUN, you first make sure you have the proper disks. You put together whatever disks you need in a RAID group, and then create the LUN on top of that RAID group. With us, we kind of get away from this concept of using disks in a RAID group. What we do is we break down disks into uniform 256 megabyte chunks, or chunklets as we call them. And then when you need a volume or a LUN, the system will go gather a number of these chunklets across as many spindles as possible and present a volume or a LUN to the host. So provisioning storage is a matter of 2 clicks, 10 seconds, you're done. No more spreadsheets, no more RAID groups. So we don't do RAID at a disk level, we do RAID at a chunklet level. So another way to think of this is we have a volume manager built into the system that lets us do all of this, sort of white striping and basically utilizing everything that the array has. I mentioned we're an active-active architecture, so a LUN that you present, you can talk to it through either controller node. We don't have this active-passive type architecture. And white striping by default, this day one, you don't have to worry about performance.
That was really the case for us. We started with a 6 terabyte system because that was a little bit more than what we had on our older array, and we knew we were growing. And we ended up with a 60 terabyte system by the time we were done with that S-series array. It grew with us. The wide striping spreads out all your I/O across all spindles, so you don't run into those issues where you have to dive deep on why one LUN is performing better than another, or add disk to one LUN or meta LUN across additional spindles to bring up more I/O capacity. It really allowed us to grow linearly over 3 years by just adding disk when we needed to. The other big feature was thin provisioning. This is not something we had on our old array. I don't know who else is doing it now, but it allowed us to provision things that we didn't have. This is different than VMware's thin provisioning, where it does it inside the VMDK. This is actual blocks that are dedicated on write, so that I can bring up some servers and provision 10 500 gig LUNs to them, but I only have 1 terabyte of storage. And as I use it, blocks get committed. As I start to run out of free space, I get a notification that says add more disk, and then I buy more disk. And it's kind of great to not have to budget up front for a project and not have to put out the money up front for one of those initiatives where a business unit tells you that we're going to need 100 terabytes because we have this analytics program that's going up, or we're going to need 100 gigs right now, but we're going to grow to 100 terabytes, whatever it is. You buy the space as you actually need it, as opposed to what they tell you they need up front.
So just a couple other notes on thin provisioning. We pioneered thin provisioning. We basically brought thin provisioning to the enterprise. And in this example here, I'm showing a 2 terabyte LUN. On the left-hand side is a traditional or fat provision volume. On the right-hand side is a thin provision volume. And really the difference is with the fat volume, you've now consumed, in this example, 2 terabytes on the array. Any free space in that volume you can't easily use amongst other hosts, other applications. On the thin provision example, you don't consume any space whatsoever until you write into that volume. There is no reservations. There is nothing that you have to set up front and reserve space or anything like that. You just say, I'm going to use a thin provision volume, and the system knows what to do. One other thing I'm going to comment here. I don't want you to think that thin provisioning is the only way to go. If you wanted to and decide to use fat provision LUNs, you can definitely do that with 3PAR as well. And the same chunklet architecture applies to both these models. We wide stripe regardless of what type of a LUN you create.
I personally have about 80 or so volumes, and 5 of them are thick provisioned. The rest are thin provisioned. It works great. It's interoperable. It doesn't really matter. It's the application. I'll get good at this by the end. So I moved away from my old array because of performance reasons. The space savings and the cost savings from thin provisioning were just gravy on top, but I really had noticeable, tangible difference. On a standard Linux server where I'd be getting about 300 IOPS, which was fine at the time, I'd move that to 3PAR and just run a benchmark and see 2,000 IOPS. Like, unbelievable, from not doing anything else in the array, not doing any fancy performance tuning, nothing. I work for a news organization, so we process lots of what we call feeds, which are data exports from various sources that go up on the website, and they're really gated by how fast they can process the feeds and turn them into XML. Before moving it to the 3PAR, I was on a local RAID controller, nothing fancy, and the box was getting about 200 IOPS. Immediately when I moved it to the 3PAR, I saw above 2,000, about 2,000 to 2,500. And then most recently, just 2 months ago, I upgraded my S-series array to a T-series, which went from 160 spindles to 224 spindles, just because we're growing. And now that volume gets over 4,000 IOPS. Just because those chunklets are spread out across all 224 spindles as opposed to 160. And this hasn't been tweaked or tuned from a host and I/O perspective. It's just kind of default. It works great. So what this really allowed me to do was keep scaling over the years and not worry about bringing in a second or third array, just add disks to this one. I didn't end up adding 2 additional nodes to my S-series because it didn't make sense to do. I didn't need it. And VMware, I was very young with VMware 5 years ago when I had the old array, but I was limited by the number of VMs I could put on a LUN. I would run out of IOPS before I ran out of space, and this kind of took care of that. Now I have over 500 VMs. It works real nice.
So the next set of challenges, you have a bunch of arrays, managing those arrays, provisioning storage. So you start off something in a RAID 5 configuration and you decide you need the performance of a RAID 1. Can you change that volume or LUN while people are accessing it online on the fly just to get better performance? So if you look, traditional arrays, what do? Again, you have some sort of a spreadsheet, you have disks that you group into a RAID group, create the LUN on top of the RAID groups. It's all manual planning and configuration. Really, you're balancing what's available on your spreadsheet and then figuring out where can you stick a volume or a LUN that you need and have enough space and spindles behind that volume. So it will take you time, it'll take you manpower, you've got to think about things. It's not easy as just point and click and you're done.
When I was in this traditional model with the spreadsheet, we used a wiki page, but same thing, I had a lot of issues. There was no central management system, so RAID controllers would be losing disks left and right across 300 individual servers, or I'd have to manage it with the EMC portal. I had a full-time guy working on storage, and I had professional services at times. There were things that we just could not figure out or could not resolve on the old array, and I have not used storage professional services since I became a 3PAR customer. The other thing that Manish talked about was changing RAID levels. It wasn't something I could do online as a non-destructive operations. I've been out here at VMworld for the past few days. I just heard that they changed the volume from RAID 50 to RAID 1 for performance on a database server. Online, it took about 40 minutes to complete. It was a pretty small one. There was no impact to the application, and now it's running on RAID 10 striped across 224 spindles as opposed to RAID 50. So it really saves a lot. So once I moved to 3PAR, I got all of their neat new management features. Rapid automated provisioning, or autonomic provisioning, I apologize, which is, Manish can talk in greater detail, but it's the ability for me to create logical groupings like I manage my ESX servers. I manage my ESX servers in DRS clusters, and I want every server in those clusters to get the same storage so that vMotion and everything works reliably. And not only do I need it to get the same storage, I need it to make sure that it has exactly the same LUN mask settings. So, a certain volume doesn't appear as LUN 2 on server A and LUN 7 on server B. It's going to cause problems. They have some new great stuff with volume sets and host sets, where we just put a host in a host set, and it's got a volume set already mapped to it, so it automatically gets those volumes. It's reliable, it's configured in one place, and when I bring a new server online, a new workhorse server that I'm going to add to a cluster, the only things I do are register it on the 3PAR, register the WWNs, and add it to a host set. It's done. By the time ESX is done installing, it sees all its storage.
Yeah, so with us, you plug the array in, and that's all you need to do, really. Spreadsheets go away. Provisioning becomes a matter of a couple seconds. So Jordan mentioned autonomic. It's not automatic, it's autonomic. The way to think of that is, if you look at your heart, when you're walking, it's beating at a certain rate. You start jogging, you don't have to tell your heart that, I'm going to go do something. It just adjusts on its own. That's similar to what we like to think about our storage. You throw a workload at us, and suddenly something changes, a new workload comes along. You don't have to tell the array, hey, I'm going to put Exchange on the array, I'm going to put Oracle on the array, I already have VMware running. We just handle that automatically, basically.
And from the getting out of the spreadsheet nightmare, it's all done in the GUI. You can just export all your list of volumes, and it's all there for you.
Yeah, so this is what Jordan's been talking about. We have a GUI. It's called the Inform Management Console. There's also a CLI available. Again, a 6-year-old can go provision storage. Your grandmother can go provision storage. That's how easy it is. And the other thing that Jordan also mentioned earlier was what we call autonomic groups. So if you have a cluster, for example, you have an ESX cluster with 4 hosts, today, when you're provisioning storage to that cluster, you have to go figure out LUN numbers, make sure they're consistent across all of the hosts, and then mapping your volumes to each and every one of those hosts is a single-step process. With autonomic groups, this becomes literally a one-step process. The idea is you group your hosts that make up the cluster into a host group, group your volumes that make up your volumes into a volume group, and then mapping the volumes to the hosts is a one-step command or process. We figure out the LUN numbers automatically. You don't have to worry about anything. And then if you add a new host to your cluster, for example, the existing volumes get mapped to it automatically. If you add a new volume to your volume group, that new volume gets exported to the host group automatically. And one other thing about this is if you have scripts that you've written, say you're snapshotting your volumes, and you add a new volume, what do you have to do today? You have to go update your script so that the new volume is part of the script. With this, since we work at a group level, you don't touch your scripts. So if you remove a volume from here, your script stays as is. If you add something, it stays as is because it's operating at this volume group level instead of in individual volume or LUN. So just a couple of features that make and kind of highlight the ease of use of this highly virtualized array. You can think of this as when we go compete against an EMC Symmetrics or Hitachi, so we're competing against the high-end SAN storage market, but with the ease of use of sort of a modular NetApp type architecture.
The other thing I wanted to make sure is clear is all the features build on each other. So, I leverage the value of thin provisioning and the value of wide striping, and now management is just cake. It's so much less work than it was before.
And there's no PS.
Yeah, none.
If you need to set up replication, less than 15 minutes to set it up and running. Same thing. I mean, upgrades, you wouldn't do them, there's an SC that you have assigned to the account, and it's online, non-disruptive. Because we're an active-active architecture, So the question was, how about upgrades? How do they happen? Again, online active-active architecture, it happens non-disruptively. Your applications, nope, there's no PS whatsoever in the company. I mean, if you want something, we'll sell it to you, but no.
It's all included. They come out and replace disks. It's great.
So,
go ahead.
I was just going to say, so Jordan talked about not being able to migrate his volume from RAID 1 to whatever, or RAID 5 to RAID 1 in his previous environment. Dynamic optimization is the tool that we use to change service levels, to change drive types. So you could have a volume that you started off using nearline drives or our SATA drives. So it might be on SATA disks, and you decide, I'm going to move it. I need better performance. I'm going to move it to a higher tier drive. With us, that movement, again, it's transparent to the host, so it's transparent to the VMs, to ESX, happens in the background. There's no impact to the array. You can change RAID levels on the fly. You can change drive types on the fly. There's no data migrations that happen. And one other thing I'll say about this is this process does not get invoked unless the array has enough CPU cycles and IOPS to services. So the idea is we will not go impact your production with this process. This is sort of a low-priority background process. Depending on the size of the volume that you're tuning, obviously the bigger the volume, the longer it's going to take. The more busy your array is, the longer this is going to take. But this will give you a totally uninterrupted way to change things on the fly. When I first started here at 3Part about 3 years ago, one of the SEs took me to an account, and this guy was changing his exchange volumes in the middle of the day while people were doing emails. Nobody complained. There was no tickets that were logged into IT saying, hey, my email isn't working or it's slow or anything like that. Again, totally transparent to the end user, to the applications. One other use case for this, so today, say you start off with 100 disks in the array. Tomorrow you go add 50 more disks. So all of a sudden you have volumes that are striped across 100 disks, and then you have 50 more disks. Well, to balance the array so that the existing volumes take advantage of the new disks, you use dynamic optimization as well. Again, totally transparent process, and the idea is your existing volumes get to use the additional spindles, and basically everybody gets elevated up by this process. Do you want to add anything?
Only that you don't need to go from a RAID 5 to a RAID 1 or a RAID 1 to a RAID 5. You can go from a RAID 5 7+1 to a 3+1. Just configure your parity. You can, I haven't gone to the SSDs yet myself. And during the migration, you don't see any impact. I guess while the transition or while the dynamic optimization is taking place, some of your data is still RAID 5 and some of it's RAID 1 as it's being transitioned over, but everything just works flawlessly. I've had DOs run for 3 days for really large, close to a terabyte volumes, but they just run in the background and they're quiet, and I just check the status and see it's done and say great and move on. So for me as a customer of 3Part, the benefits are pretty clear. Performance was the number one reason we moved over. Performance was our big problem, and it wasn't cost or capacity or whatnot. We got cost and capacity savings for free. They just came along with it. Besides the traditional cost savings that I talked about from thin provisioning, is we didn't have to scale out to multiple floor tiles. And that's a really large recurring cost in some data centers, with space and power being a premium. So I'm able to put 60 terabytes in one floor tile as opposed to spreading it out across 2 or 3. It's a very dense architecture. And management is simple. No professional services. It takes, about 10% of one sysadmin's time to manage it. I spread it across 2 people. It really doesn't take much. We check on it. We spend more times looking at very small blips in the graph that are well in the sub 8 millisecond range that are just a waste of time that we look into to make sure that there's no issue, but there's no issue. And we focus our efforts on other things like scaling our VMware or scaling our network, because our array is good. It works nice.
Yeah, so, if you haven't been by our booth, by all means stop by. There's more technology. I mean, we didn't talk about a lot of things in this presentation because this was not a 3-part only presentation, but we have a plugin into Virtual Center. There's other tools other than dynamic optimization that are available. You can go get a feel for it at the booth. There's a couple arrays out there, pull some magazines.
I use remote copy over IP to do replication between 2 sites. Works real seamlessly. It's nice and straightforward that it's a plain old IP stream moving across sites, and I don't have to worry about complex negotiations with each side of the array, or each array on each side initiating the communication. It just kind of makes it a no-brainer. It takes a really complex thing and makes it something we don't have to worry about. So.
Is that the last slide?
And that's
questions?
It. Any questions? We're happy to talk.
Do you want to
come up to the mic?
Here to the mic? No. Nope. Yep. So this wide striping or massive parallelization, we utilize every resource in the array. All the disks, all the controllers. You don't say I'm going to create a volume and this volume or LUN is going to be assigned to controller A and this one is going to go to controller B. You don't do that with us.
And from a fiber channel perspective, I zone all my servers to see every node, and there's no preference on which volume they pull from. So on a 2-node system, all my servers see a couple initiators or a couple targets on each side, and on the 4-node system, it's just the same.
So in an ESX environment, for example, if you're running ESX4 and beyond, round-robin pathing is fully supported. Because we're an active-active array, you can switch from fixed to round-robin pathing and take advantage of the active-active controller nodes.
So you don't need third-party multipath?
Not at all. Yeah, absolutely. You don't need a third-party multipath plugin for us because we're active-active. We take advantage of round-robin pathing. And you don't have to license anything additional.
On the Linux servers, I use the built-in multipath D that just comes stock with everything recent. I have a couple of Windows servers that are directly attached, and I think they use the built-in MPIO, but there's nothing extra to do.
Yeah. Yeah, so again, if you go to the booth, we have some slides on that. Yeah, we're going to come out with our plugin this month for VAAI, and if you don't know what that is, that's vStorage API for array integration. And there's 3 things that are part of that. They're going to move away from SCSI reservations to what's called hardware locking or atomic test and set, and basically then pushing off the heavy lifting to the array. So if you're doing a storage vMotion, for example, it'll call xcopy to do the movement of the data instead of having ESX do that. And then the third thing is write same. But yeah, we're fully supported for that as well. Okay. Say that again? No, so today xcopy is going to work within the system, and that's how ESX chooses it. But if you have a volume from, say, 2 different arrays, and you're running VAAI and you do this or storage vMotion, for example, of a VM from this data store to this data store, at that point, ESX would still be doing the movement. It's just within the array will handle it. And the array is going to be obviously more efficient and more faster in doing that. Yes?
You have a synchronous array synchronous replication?
We do both. Yep. And we can go over fiber channel, over IP. You don't need any additional hardware in between. People end up sticking something like a riverbed if they want to accelerate the WAN. But from our perspective, it's not needed. It's thin provisioning aware. So if you have a source volume, say it's a 100 gig volume, you're only using 2 gigs. The initial replication is that 2 gig, and after that, it's whatever delta changes happen on the source volume. And we're integrated with SRM as well. So if you're using SRM for DR, we have an adapter that ships for SRM. It's been shipping for over 2 years. We've got a bunch of customers that use us for that.
Any other questions? All right. Well, great. Thank you for attending.
Thanks.